Today we are going to be talking about piecewise functions. We're going to start off with a brief review of absolute values just to make sure that's going okay for you. Inside the absolute value here is going to be the x value of your vertex, but you're going to do the opposite of that because this plus 4 actually moves the graph left 4, and so we're going to write a negative 4 for the x value of our vertex. The a number out in front is the stretch, so we have a vertical stretch of 3. And then the k number at the end is the up and down. So we are going to be moving down 8. And that k value there is going to be the y coordinate of your vertex. So whatever's inside, you do the opposite of that. And then the y coordinate is just whatever is at the end. Your axis of symmetry is going to be x equals, and it's always going to go with your x coordinate of your vertex. So x equals negative 4. So now in order to graph this, we're going to go negative 4 comma negative 8 and put our point. And we're going to do our vertical stretch of 3, meaning our next point is up 3 and over 1, kind of like a slope of 3 on each side. So our absolute value graph is supposed to be that V shape, and looking at the graph you can see that V. You can also see that it is moved left 4 and down 8 with a vertical stretch of 3. So now our domain to the left and to the right, this graph will keep going for forever. Your range is low to high. This graph goes down to negative 8, and it goes up for forever. Increasing and decreasing, if you trace your graph from left to right, we're going to start off by decreasing, and then at our vertex, we're going to switch to increasing. So if you're looking at this here, we start off decreasing and then move to increasing, and that switch happens here when x is negative 4. So if you think all the way to the left as negative infinity and all the way to the right as positive infinity, we then have our intervals. So looking at this, our decreasing interval happens from negative infinity to negative 4, and our increasing interval then is the other half, so from negative 4 to positive infinity. So now what we're going to do is we are going to then apply that idea of increasing and decreasing to the graph of a piecewise function. So we're going to start off by graphing these much like we did in the last lesson. So we're going to top our graph here at our boundaries of negative 4 and positive 1. The first one, x is less than or equal to negative 4, is going to be the leftmost portion of this graph then. The next portion, everything in between negative 4 and 1 is the middle, and everything bigger than 1 then is the right. So we want to graph the top equation on the left, the middle equation in the middle, and the bottom equation on the right. So we're going to start off by graphing negative 8x minus 8. So we're going to start off with our slope, or our y-intercept being negative 8. Again, be careful that you are not graphing that on your boundary line, but that you are graphing that on your y-axis. Now you're going to do a slope of negative 1, which is down and to the right, or up and to the left. And you're going to graph a bunch of points because we want to make sure that these points make it in to that yellow section over here, all the way on the left. So the graph we're actually looking at is this one over here. On our boundary here, we're going to have a filled in circle because of the or equal to. And then we can erase the portion of the line that we actually did not need for this one. Our middle equation is y equals 3x plus 7. So we're going to go to 7 on our y-axis, and we're going to go ahead and do a slope of 3. So up 3, right 1, or down 3 and left 1. We don't need to keep extending because we want this blue section to be in this middle part here. So then all we have to do is connect these and worry about on our boundary open or close. So it's going to be an open circle for negative 4 and a filled in circle at 1. Our last equation here is going to be y equals negative 4. That is a horizontal line. Normally it would go all the way through like that, but we don't want the entire thing. We only want the section of the line on the very right. So we're going to go ahead and graph y equals -4, but only from 1 to the right. And at 1, it is going to be an open circle on that boundary. So now we have 3 different chunks here. And so what's happening is each of these chunks is going to be increasing, decreasing, or a constant. And so looking at this one, we can go ahead and identify this first chunk here. If you start tracing from left to right, your graph is going down. So this is decreasing. The next chunk, then, if you trace your graph from left to right, starts increasing. And then after that, you have the constant. And you know it's going to be a constant when it's a horizontal line there. That's always going to be constant. So looking at this, the turning points happen at -4 and at 1. That's where you're changing from decreasing, and then the next interval is increasing, and then the constant. And so all the way on the left of our graph is -infinity. All the way on the right of our graph is positive infinity. And what that means is that this first interval is decreasing. So we're going to use from -infinity to -4 as our decreasing interval. Everything for increasing was this middle interval here. So that's going to start at -4 and go to 1. And our last interval here was our constant interval. And so our constant interval starts when x is 1 and it goes to the right for forever. So for a reminder for this, you always use x values only and you go left to right. And you're always going to use parentheses for these ones because a point itself is not increasing or decreasing. It's just a point. So that's the first new application here, is applying that increasing, decreasing, and constant to piecewise functions. For the next one, what we're going to do is we're actually going to be evaluating these different functions. So we can look at the graph to do this, or we can look at the equation. So this first part here is asking us, when x is 7, or -7 rather, what is your y value? And you're used to doing these problems, but you're used to only having one equation like this. And I would say, what was f of -7? And you'd say, oh, all I have to do is I have to plug in -7 and figure out what that equals. The problem is for this one, I'm going to erase all my colors up here. The problem is for this one, we are looking at all of these different pieces here. We have this top rule, the bottom rule, and the middle rule. So we cannot take and plug in -7 for all 3 of those and get 3 different answers. We can only plug it in for one of them. So in order to figure out which one to plug it in, we have to remember that this piecewise function is telling us the rule. So this is what to do, and this is when to use the rule. So this is when to use that rule. So when you're looking at x equals -7, you have to ask yourself, does that work in the top, middle, or bottom equation? So if x is -7, that is less than -4. So this is saying use the top equation. So what we do then is we say, okay, we're going to do -x minus 8, but we're going to plug -7 in for x. When we do that, we end up getting a +7 minus 8. So overall, when x is -7, y is -1. And that works with our graph, because if we go to the point -7, you see the point -7 for x, -1 for y is on our graph. We're looking for that y value. So how about the next one? This one is saying x is 8. So look at your rules. Is x less than or equal to -4, in between -4 and 1, or bigger than 1? And when x is 8, x is bigger than 1. So that means you're going to use the bottom equation for this one. So our equation for this one is just y equals -4, which means there's no x to plug in. So when you plug in 8, you just get -4 out because you get -4 out for everything. And if you look at your coordinate point 8, comma, negative 4, that is on our graph. So our next one, f of 0. This one is saying here x is 0. And so you have to ask yourself, does that go for the top, the middle, or the bottom rule up there? So 0 is in between negative 4 and 1. So this is saying use the middle equation. And for our middle equation, it's 3x plus 7. So when I plug in 0 for x, I get 3 times 0 plus 7, which gives us 7 back out. And you can always check with your graph, when x is 0, y is 7. Okay, let's try one more here, f of negative 12. This one is saying here x is negative 12. So think about, is it the top, the bottom, or the middle one that it works for? Since negative 12 is less than negative 4, this is saying plug this into the top equation. So we're going to do negative x minus 8, and we're going to plug in negative 12. That becomes a positive 12 minus 8, or 4 in general. So these ones, again, figure out which rule are you plugging it into, and then plug it into that rule. We're going to do the same thing once again here, but now with just an equation, no graph to back it up. We either have the top equation or the bottom equation. So take a moment and look at each of these values and figure out if these x values mean that you're going to use the top equation or the bottom equation. So for 12, we should have said that is bigger than 8. That's the bottom equation. For 8, we should have said that is equal to 8, which means it's the bottom equation. For 4, 4 is less than 8, so that's the top equation, as is negative 3. So now what we're going to do is we're going to take each of these rules and we're going to plug in the numbers into the appropriate rule. So for 12, we're going to do half of 12 minus 2, which ends up giving us 4. For 8, that's the bottom equation, so half of 8 minus 2, which ends up getting us 2. For 4, we're using the top equation, so we're doing negative 4 plus 12, which is 8. And for D, we're doing the top of equation, so we're doing negative 3 plus 12, which ends up being 15. So that's how we evaluate different functions. Number 4, I'm going to make optional. If you would like to try this, go ahead and pause the video, try it out, and then come back and check your answers. If you think you're good to go, you can then move on to the next couple. So if you tried this one, you would get 8 for the first one, 20 for the next one, negative 3 for C, 6 for D, and negative 9 for E. So now what we're going to do is one last skill. We are going to take these equations and we are going to write piecewise functions based off of the graph. So looking at this one, what we want to do is there's two parts here. We're going to need to come up with both the rule and when to use the rule. So for each of these ones, it's kind of, like I said, two different parts to each of them. So for this one, I can tell that there's two pieces here. So we can figure out when to do each of these by looking at the boundaries. So these chunks here happen at negative 4 and positive 1. So our first chunk here are for the x values in between negative 4 and positive 1. And notice each of these has a filled in circle. So for each of these, you have the or equal to. For the next one here, it's between 1 and 3. We have an open circle and a closed circle. So one of those is open and one of those has the or equal to. So what I'm going to do here is I'm going to pause this video and I'm going to start up again right from here on the next one just to make sure we have enough time to talk about these.